Okay, this lesson's about cofunctions and simplifying trig identities. So first here on the right hand side, let's consider this little triangle here that I have drawn for you. I have a 30, 60, 90 right triangle. And so if I were to ask you, what would the sine of 30 degrees be based on the triangle? And in real life, the sine of 30 degrees, right, is always the opposite over the hypotenuse. So that would be 1/2. And then if I asked you for, the cosine of 60 degrees, well, I would do the 60-degree angle, and the cosine of 60 degrees is the adjacent over the hypotenuse, which is also 1/2. So you notice that the 1/2 and 1/2, they're both equal, right? So that tells me that the sine of 30 degrees is equal to the cosine of So this is not like some coincidence, right? But I do want to point out one thing to you. So notice that 30 and 60 together add up to 90 degrees, right? Known as a complementary angle. And the thing that we want to talk about here is that sine and cosine are what's known as cofunctions. You might ask, what does cofunction mean? Well, a cofunction just means complement to the function. So here they are. I have them lifted out for you, right? Sine and cosine are cofunctions because it means complement sine. Secant and cosecant are cofunctions because cosecant means complement secant. Tangent and cotangent are cofunctions because the cotangent means complement to the tangent. Okay? So we could do a lot with this. We could say that if I was going to figure out the secant of 10 degrees has to be the same thing as the cosecant of 80 degrees. And again, the reason is because 10 and 80 add up to 90 degrees, make a complementary angle, and secant and cosecant are cofunctions. Okay? So if I were to ask you, the tangent of 50 degrees would be equal to the cotangent of what? What would you have to do to figure it out? Well, you take 90 minus 50, and you get 40. So the tangent of 50 degrees is equal to the cotangent of 40 degrees because that adds up to 90 degrees, and tangent and cotangent are cofunctions. This also works on your calculator, and I want to show you how to do it. Okay? Your calculator has two modes. If you push the mode button, notice down here you can get radian or degree. You need to be very careful in which one you're in. If you're asking the calculator for a degree, you need to put your calculator into degree mode and then get out of it. So let's do the first one, right? The sine of 30 degrees, push enter, and I get 1/2, of course, as equal to the cosine of 60 degrees, again, equal to 1/2, because 30 and 60 add to 90, and sine and cosine are complementary functions. Now, some people are asking, how do you punch in tangent? Okay, so as an example, if we wanted to do the tangent and the cotangent one, if I plugged in tangent of 50, pushed enter, I would have to plug in 1 divided by, divided by the tangent of 40 degrees, because that is equal to the cotangent, and notice they're exactly the same thing. So you punch in 1 over the tangent of 40 to be equal to the cotangent. That's how you do it. You take the reciprocal function. So that's the idea behind cofunctions. The other idea that we talked about was simplifying fundamental trig identities. And we're going to do 5 problems here. And I've written down for you all of the trig identities that we've talked about on Monday and Tuesday. Okay, we had the reciprocal identities where it was 1 over something. We had the quotient identities where it was tangent is sine over cosine and cotangent is cosine over sine. And then we had 3 Pythagorean identities. All right, so let's take a look at the first one here. I'll do these all in green so you can see. The secant squared of 28 degrees minus the tangent squared of 28 degrees. Well, because I'm using squareds, I know that I'm using something along the Pythagorean identities, okay? So, what I can look at and I can see, all right, I know that 1 plus the tangent squared of theta is equal to the secant squared of theta. And right here, I have the secant squared of something, 28 degrees. So I can replace secant squared of 28 with 1 plus tangent squared of 28 degrees, minus this piece over here, which is just the tangent squared of 28 degrees. Now 1 plus tangent squared of 28 degrees minus the tangent squared of 28 degrees. These two pieces cancel out. So all I'm left with is an answer of 1. So secant squared 28 minus tan squared 28 is an answer of 1. And we use the Pythagorean identities to get us there. Okay, let's talk about this one. The cotangent of 10 degrees minus the tangent of 10 degrees. Well, I know that the cotangent over here in my reciprocal identity is equal to 1 over tangent right there. So I can write this part as 1 divided by the tangent of 10 degrees. And I can multiply that by this part, which is just the tangent of 10 degrees, which of course is just the tangent of 10 degrees divided by the tangent of 10 degrees, which of course is just also 1. So all of this information is again equal to just 1, and we use the reciprocal identities to get us there. Okay, let's do the cotangent of 25 minus cosine 25 over sine 25. Okay, well, cosine over sine, if I look right here, right, cosine over sine is equal to cotangent. So I can rewrite this as cotangent of 25 degrees minus all of this now becomes the cotangent of 25 degrees because of the quotient identity, and all of that just becomes 0. So everything becomes 0 in this case. For number 3. Okay, number 4, tangent of 12 degrees minus the cotangent of 78 degrees. Okay, do you notice that 12 and 78 add up to 90 degrees, and that tangent and cotangent are cofunctions of one another? So I know that the tangent of 12 degrees is actually equal to the cotangent of 78 degrees because they're cofunctions. So therefore, since these two things are equal and I'm subtracting them, I again get 0 for an answer. Okay, and then the last one here. 1 plus the tangent squared of 5 degrees minus the cosecant squared of 85 degrees. Well, I know that 1 plus tangent squared of something is the same thing as the secant squared of something. So all of this can be simplified to the secant squared of 5 degrees minus the cosecant squared of 85 degrees, based off of the Pythagorean identity. Now I'm also noticing that 5 and 85 are complementary, and secant and cosecant are cofunctions, so the secant squared of 5 is equal to the cosecant squared of 85, and I'm subtracting them together, so again I get 0 here. Okay, there's the main idea behind that. We had cofunctions and we had simplifying fundamental trig identities. Don't forget about these over here in the box, the reciprocal identities, the quotient identities, and the Pythagorean identities.